Hello everyone, myself Himani Sharma from RPT campus. In today's class, I discuss about the types of redox indicator. That are the four types of indicator: internal indicator, self indicator, external indicator, and instrumental indicator. First is the internal indicator. These indicators are mixed directly with the solution and change the color when chemical reaction happen. Examples are the ferrione change from the light blue to red, and start iodide turns from blue to colorless. Next is the self indicator. These substances you are added to the solutions change the color itself when the reaction is complete. Example is the potassium permanganate turn to the solution pink and iodine turns to the solution brown. Next is the external indicator. Instead of adding the indicator to the solution, you take a small sample out and test in which the indicator to see if color is changes. Potassium ferricyanide is used to check if a reaction is complete. Next is the instrumental method. Sometimes instead of using color changes, special instruments like a potentiometer or conductometer are used to find out when the reaction is complete. Examples is the potentiometer helps to detect the endpoint electrically. Types of redox titration are the bromometry, iodometry, and dichrometry, seriometry, iodometry most important, and there are the titrations with potassium iodide. First is the iodometry. Iodometry is a type of redox titration that involves direct titration with iodine I2. It is based on the reactions where iodine is converted into iodide ion, that is I negative. Iodine is the I2 and that is converted into I negative is the I minus 1. First of all, we take a burette and a flask and a clamp in which the sodium thiosulfate is added and the flask iodine is added as an the oxidizing agent. First, all the iodine has reacted, the solutions become colorless. Water is added to make up the volume. Starch is added as an indicator and reaction is take place, that is I2 plus 2Na 2S2O3 and 2NaI is the N2S4O4 and I2 starch complex is 2. These are the blue color and all iodine has reacted, the solutions becomes colorless. Principle: iodine acts as the oxidizing agent in this titration. A standard iodine solution is used to determine the concentration of reducing agents such as the sodium thiosulfate, arenous acid, H3ASO3, etc. The endpoint is determined by using starch as an indicator where the solution change color from blue to colorless. In today's class, I discuss about the following iodometry principle. Thank you for watching.